All right, in this video, we're going to try to walk you through questions 5 through 9 of the Electrolysis Lab. It's continuing on with 1 through 4 that was in that previous video. All right, so before you can do 5 through 9, you need to consider the balanced reaction for the equation that you needed to look up in the earlier work you had done, which is two water molecules, that's H2O liquid, L for liquid. When we put the electrical energy across them, we produced 2 molecules of hydrogen gas for every 1 molecule of oxygen gas. So that's the balanced reaction where water molecule breaks apart into hydrogen gas and oxygen gas. And remember, hydrogen gas, like oxygen gas, is H2, 2 molecules of hydrogen bonded together to produce 1 molecule of hydrogen gas. And we need the 2 to balance it because there's only 1 oxygen atom in each water molecule versus the 2 hydrogen atoms. So you are going to produce twice the volume of hydrogen. So the hydrogen volume will be 2 times the volume of oxygen. Also, there will be 2 times as many hydrogen gas molecules as oxygen gas molecules, and 2 times as many hydrogen atoms as oxygen atoms. So down to the problems. From that information, number 5, the hydrogen gas volume will be 2 times the 5 milliliters that the oxygen was, or 10 milliliters of hydrogen gas. So number 6 then is like number 1, starting with a different volume, and you have 0.01 liters. 0.01 liters divided by the 24.0 liters in 1 mole gives you this many moles of hydrogen gas, 0.004167. Number 7 was like number 2. You could work at using Avogadro's number, except since I know there's going to be 2 times as many molecules, as oxygen molecules, I'm going to use my number of oxygen molecules for number 2, which is right here, and simply multiply it by 2. It gives you this many molecules of hydrogen gas, 2.51 times 10 to the 20th. And then number 8 is like number 3 above. It asks for how many atoms of hydrogen gas. So you take 2 atoms in each hydrogen gas molecule, multiply it by the number of molecules, which we got here, then you get this many atoms of hydrogen, 5.02 times 10 to the 20th. Then number 9, where it asks for the mass, is like number 4 above, except you need to use hydrogen's mass. So we have this many moles of hydrogen. You calculated that in number 6 times 2.0 grams per mole of hydrogen. So there'll be 2.0 grams of hydrogen in each mole of hydrogen gas. Hydrogen is 1.0 for atomic mass in the periodic table. You have 2 atoms in a molecule, so you take the number of moles times 2.0 grams per mole, and it gives you this many grams of hydrogen gas. The problem asks you to express it in milligrams, so we multiply the number of grams by 1,000, we get 0.833 repeating milligrams of hydrogen gas. Now, one interesting side note is when you look at the ratios, you produce twice as many moles of hydrogen as oxygen, twice as many molecules of hydrogen as you did oxygen, but the mass of hydrogen is only 1/8 the mass of the oxygen gas, because even though we have twice as many hydrogen molecules, oxygen gas is 16 times as heavy as hydrogen gas because there's more neutrons and protons in the nucleus of a hydrogen atom. So those divided, you get a ratio of 8 to 1. It's not 16 to 1 because you have 2 times as many hydrogen molecules. Well, thanks for listening. I hope this helps.